So in a previous video I talked about troubleshooting on the contactor. How do you troubleshoot this bad boy right here? Well, that's your compressor. You don't want to just assume compressor's bad and start there. Look at your symptoms. If you've tripped the double pole breaker that sends 220 volts or 208 if it's commercial to here, and it tries to run again and trips a breaker, this is a bad boy I'd check right here, especially if the condenser looks, well, like that. Okay, you can start your troubleshooting journey here at the contactor. You can check for your voltage here. You can take the thick wires off right here, but don't touch anything here unless you turn off the power at the disconnect. There's no disconnect circuit breaker. There's no circuit breaker. Explain to the homeowner how it's too dangerous to work on until you make it safe and adjust the price accordingly or walk away from the job. You can pull these wires off, pull that wire off, and ohm out the compressor that way. The problem with doing that is, well, you have this box right here on the compressor. On this box, of course it wants to be difficult. Behind there is your wire terminals. Just like that. That is where you want to troubleshoot your compressor. One, those terminals are a safety, as in overpressurization happens in the system. This is your pressure relief. So those terminals can blow out. You go to remove these wires, be careful with it. Don't yank, jerk, wiggle as hard as you can, because you can actually break those terminals. And if you break them, well, you're in a whole new mess right there. So carefully remove those plugs. You can have your run, common, and start to ohm out the compressor there. Do not, under any circumstances, try to ohm your compressor to ground by going like this and like this. Do not do it here. That black paint creates an insulation. What I've done is I'll take a file, scrape away that paint on there, then you have bare metal to go to. You can sometimes go to the copper. I prefer just to make a scratch on this enamel on the top to get to the bare metal and go for readings that way. You have to disconnect all your wires here, because those wires are connected up to that contactor, which includes the condenser fan motor, which, if you go, I have a reading here on ohms, but the compressor is not running, it's got to be good. No, this could have an OL on it, whereas it's going to go back through the contactor in that junction box, because you see how it's all connected there, or you saw from the previous video, to the condenser fan. All you want to do, let's see, there's a big old spider on there. I don't want to get my hands on it. I don't like spiders. But you just go from terminal to terminal. You're trying to look for any OL. So you're going to go from run, common, start, or start, common, don't matter, and see what you have that way. If you get an OL, well, if you get OL between run and common and OL between start and common, congratulations. The internal overload has opened on here. If the compressor is hot to the touch, the internal overload is doing its job. If the compressor is cool to the touch, the overload on the internal overload is actually bad. It's going to be a little sensor embedded in the motor windings to open up to kill power to try to save the compressor. Okay, so that's where a lot of that's going to come into play. Now if you go run to common, get OL, start to common, let's say 4.5 ohms. Your run winding is open. It's a bad compressor. There's no fixing it. If your start to common says OL, run to common says 1.2 ohms, well, you got a bad compressor still because the start winding is open. Ideally, in laboratory and textbook environments, your run and start windings will equal the total windings combined on there. So if you go R to C and get 1 ohm, start to common, S and C, let's say is 3 ohms, then when you go to R and S, you should have, well, 1 plus 3 equals 4. When the compressors get used and used and used and start getting some wear and tear, and life expectancy starts going down on them because they're getting older, you might get 1.1 ohms run, 4.5 ohms start, 4 ohms even between the run and start. Doesn't mean it's exactly a bad compressor, but you do know it's used, you do know it has some age on it, you do know that it's eventually wearing down. You also want to check too, if you got a mega ohm meter or meter like mine that does mega ohms, pull all those connections off, go to terminal to ground, and see what the mega ohms are. If your mega ohms are getting, let's say 1.4 million ohms, this thing is going out. It's on its last leg. It's just a matter of time. If it's 30 million ohms, well, you've got some life in it still, but don't expect to get 20 years out of it type of thing. You can maybe expect 5 years, provided you keep up with the maintenance on everything. So there's some information on troubleshooting compressors and ohming them out. Like and subscribe and share the videos if you're getting helped out with them. Remember, when it comes to high voltage stuff, only trained professionals should mess with that. Remember to subscribe so brother can get paid. Take care.